Suppose we want to test whether two different wheat varieties impart different flavors in a bread. Here's what we did to test that. We made bread loaves that used an identical recipe in every way. Same amount of flour, same amount of water, same amount of yeast, cooked it identically. We kneaded it using machines, so there wasn't a difference in how they were kneaded. So the only differences in these breads was the wheat variety used to make the flour. And then we performed something called a duo trio test. And it works like this. On the other side of this room, on the other side of this wall will be people or tasters. And we're going to put 3 slices of bread on a plate for them. And we're going to give them labels. One, we label R for the reference slice. And the other 2 slices will have a 3-digit number, a randomly generated 3-digit number. Maybe 3, 4, 7, and maybe the other one will be 6, 9, 2. And we're using 3-digit numbers because we wanted the number and the bread it's associated with to have really no connection. We don't want to label one A and another one B because we tend to think A is better than B, like your grades. A was better than B. So we want the identification to be meaningless. And then, so we're going to put 3 slices of bread on here. Now, 2 slices are going to come from the same wheat variety. So maybe the Gallagher wheat variety is used to make the bread that goes on the reference slice and 347. But then the other slice will come from a different wheat variety, maybe Smith's Gold. So we have Gallagher, Gallagher, Smith's Gold. And we put the slices of bread on there, and then we put the plate in there, and then we turn it around. And now let's go see what it looks like on the other side of the wall. Okay, stop it. Here we are on the other side of the wall. Now, I'm a taster. I'm a sensory analyst. And usually for tests like this, you don't bring in people who specialize in tasting food. You just bring in normal people. And then you saw me turn the little Lazy Susan, and when it turns, it's going to be revealed here. And we do this so the people here don't see what's going on back there. This is like a blind taste test. And then they're going to take the plate, and it's going to have the 3 slices of bread. And then there'll be instructions that they first taste a reference slice, then they taste 347, then they taste 642, and then they tell us which one slice was different from the reference slice. And so remember, we said Gallagher was the reference, Gallagher variety was 347, but Smith's Gold was 692. If they, on the paper, correctly say 692 is different from the reference slice, they got it correct. But if they say 347, they got it incorrect. Now, of course, they have to choose one or the other, so if there was really no difference, it would be like a coin flip. 50% of the time they'd get it right, 50% of the time they'd get it wrong. And so the way we judge whether people can correctly tell which one is different from the reference slice, and in this case, whether they can really tell the differences in bread made from different wheat varieties, is whether the percent of times they got it right was above 50%. This is an experiment, and I want to go over a little of the details about doing an experiment. A general rule in research is you control what you can and you randomize what you cannot. So what do we mean here? The main purpose of this experiment is to determine if bread tastes different when you use different wheat varieties. So we want the only differences in these breads to be the wheat varieties. This means we want to control for other things that might impact the taste of bread. And so we don't want the breads to have different levels of salt, or one to use a white flour while another's using whole wheat flour. And so we use an identical bread recipe where the only differences between those slices of bread is the wheat variety used to make the flour.
But now there are some things that happen in experiment that can affect people's choices. So they've got to taste one sample before the other. And the order in which they taste the samples may impact their answers. And so what we do there is we randomize the order in which they taste the samples so that they're very randomly across people. So that's why we say we randomize what we cannot control for. And let me give you an example here. Remember we said suppose that the Gallagher is the reference slice, and then they taste 347, which is the Gallagher variety. Then they taste 692, which is a different variety. Well, for other people, we may change it up a bit. For other people, the subjects in the study, Smith's Gold variety may be the reference slice. And then maybe instead of tasting 347 first, maybe we have them taste 692 first. The point is we randomize all those little details that could have small effects on people's answers. Well, you might ask, what if people can't tell which one is different from the reference slice? Well, you have to make them choose something. So if they're unsure, they have to guess. And so what that means is that if people cannot tell which sample is different from the reference slice, they're going to guess it correctly about 50% of the time. So this means you can only really say that people can tell differences in the samples if they provide the correct answer, identify the correct one that's different from the reference slice, much more than 50% of the time. And if you say, well, how much more do you need? Well, that's what you take statistics to learn. That's what statistics is for. And here is what we found. We found that for some varieties, for instance, when comparing Gallagher variety to Ruby Lee, that people could identify which one was different from the reference sample 68 to 75% of the time. And it turns out when you crunch the numbers and do the statistics, that's sufficiently higher than 50% to say that in general, people can taste the difference in bread made from Gallagher versus Ruby Lee varieties.
Flavor is a psychological concept, and how food tastes can be impacted by the environment around us, even things on a wall. So when we're doing a very scientific test of tasting, a very scientific sensory analysis, we want to do it in an ISO standard room, a room that is specifically designed to be bland. And so you can see in this sensory room, all the walls are just lights. The sensory analysis, our subjects, they're going to sit here, and we have dividers so they can't look at each other, can't see what each person is answering on a questionnaire, they can't talk to each other. We have computers in case we want them to answer things on the computer. Nothing on the wall, there's no red colors that would suggest sweetness, for instance. And then sometimes we want people to be able to judge the taste of food without the color of the food matters. We want to see what the taste is independent of the color. Well, we have a really neat way of doing it in this room. What we can do is we have above each of these stalls a red light. And we can then bring them food, give them food to eat, but before they see the food, we turn off these lights, and it's going to make all the foods have this reddish color. And so all the foods will have the same color, and then you can see what taste looks like, what taste is without color impacting it. So to show you how these lights can help you evaluate taste independent of color, I want you to look at the colors of these marbles right here. Clearly, when you see those, they look different. You see red, you see orange, you see yellow, you see white. But now watch what happens when I turn off the main lights and we only have these red lights. Now there are no differences in color. And so color, if you tasted those samples, what you taste would be independent of the color.